we discussed in the case of differentiability, like if we are discussing the derivative of a function at a given point, so geometrically it signifies that we're calculating the instantaneous slope. This is x is equal to a. So we are checking out, if I'm saying that I have to see the derivative of fx at x is equal to a, what I'm trying to say is that I'm seeing the instantaneous slope, the instantaneous slope of the function at x is equal to a. And that's how we discuss the left hand derivative and the right hand derivative. So that's the geometrical significance of derivative of function. Now we'll try to see the physical significance. So we can say that geometrical significance is that it gives us the instantaneous slope of the function. And what do we mean by the left hand derivative and the right hand derivative? That is pretty much clear to you. I think so. So let's see this property, this geometrical significance, with the help of a question. So the question is that find the slope of the function. So this fxn, this is my short form for function. Function is fx is equal to y is equal to 1 upon x. Now this is a very common doubt everybody gets is, why am I saying that fx is equal to y? Because whenever we try to make the graph of this function, all the values of x which I am going to take will be denoted on the x-axis, and the values of fx, the value of the function for the corresponding value of x which I am getting, that will be denoted on the y-axis. So this is said to be y is equal to 1 upon x. So that's why I write y is equal to 1 upon x here. So let's try to see the slope of this function at x is equal to a. So this is the first part. The next part is, what is the slope at x is equal to -1, and when is the slope is equal to -1 upon 4. So these are the three parts of the question. The first part is the function is given, you have to generalize the slope in the terms of x is equal to a, and then you have to tell me what is the slope at x is equal to -1, and then when is the slope -1 upon 4. So let's first, to find the slope, so this is the solution. To find the slope, what we have to do is fa plus h minus fa upon a plus h minus a. So this is the f dash a, or we can say that this is the right hand derivative. So assuming that this is continuous at x is equal to a, for the discontinuous values of or non-differentiable values of x, we will change the nature. Okay, but since this is continuous and differentiable for all the values of x except x is equal to 0, this is pretty much clear from here. When we substitute the value of x is equal to 0, this becomes not defined. So it must be continuous. It will be continuous and differentiable for all the values except x is equal to 0. So let's see that f dash a can be written something like this. This will be equal to 1 upon a plus h, 1 upon a upon this will become h, right? So this is a minus a plus h upon a into a plus h upon h, right? So this can be written as minus h upon h into a plus h. So this comes out to be -1 upon a into a plus h. Now since we know that the limit h here is h tending to 0, that h is a very, very small number which is being added to a here. So this can be substituted at 0. Now because we cancel this out, this is no longer 0 upon 0 form. Therefore I can substitute the value of h is equal to 0. This comes out to be -1 upon a square. So we can say that the generalized slope of this function at any value x is equal to a is -1 upon a square. So let's write it down. That f dash a. Now this dash signifies, this dash will signify the slope at x is equal to a. This is equal to -1 upon a square. So now let's try the first part. It is we have to find the slope at x is equal to minus 1. Therefore, f dash minus 1 will be equal to minus 1 upon minus 1 square. This comes out to be minus 1 only. Right? Now the second part is, when is the slope minus 1 upon 4? Now it is given that f dash x is equal to minus 1 upon 4. Now we know that this is equal to minus 1 upon a square. The slope generalizes is minus 1 upon a square for the value of x is equal to a. So we can say that we can equate these two and we will get a square is equal to 4. So at the values of a or at the values of x is equal to plus minus 2, this slope will come out to be minus 1 upon 4. So the answer for this part is minus 1, and for this x is equal to plus minus 2. So this is how we try to see the geometrical significance, which always gives us the instantaneous slope of the function at the given point x is equal to a. So now let's see the physical significance of the derivative of the function. Now what does the physically, it signifies the rate of change of the function. Now what do I mean by the rate of the change of the function is that this geometrically signifies the slope. Like let's say this is a function which is dependent on time, right? This is ft and this is t. Now at what rate the slope will give us the rate, at what rate is the function changing, at what rate is the function changing, that will be the instantaneous slope of this function at a given point.